These are the notes for Algebra 2 covering monomials. First, we're going to start with a warm-up of what we did before, multiplying and dividing our rational expressions. So this is just a lot of factoring here. Let's set this first one up. Anytime you don't have a number in front of your x in the middle, right there, you're going to put a 1. The numbers that multiply to make 56 and add to make 1. That would be positive 8 and negative 7. Then in the denominator, numbers that multiply to 21, that's going to have to be 7 and 3. And because those have to add to negative 10, they're both going to be negative. Numbers that multiply to negative 33 and add up to 8. So I'm going to have to use the 11 and 3. And then the 11 is going to be positive and the 3 is going to be negative. Remember, you can always check these in your calculator. Make sure your signs are correct. In the denominator, numbers that multiply to 16 add to 10. That's going to have to be 2 and 8. All positives means both of those signs are going to be positive. And then because we're multiplying, we have one big problem here. So it's almost like that's all connected. And you can cancel anything in the numerator with anything in the denominator. X plus 8 cancels with x plus 8. X minus 3, x minus 3. X minus 7, x minus 7. Leaving us a final answer of x plus 11 over x plus 2. For the second problem, since it's division, we want to make sure that we flip the second fraction and change this to a multiplication problem. Again, the second fraction, so the x plus 3 would go in the numerator, and the x minus 6 would go in the denominator. You could put parentheses around those if you like, just so it looks a little closer to the other ones. Another 1 in front of that x. Numbers that multiply to 30. Let's see, 1 times 30, 2 times 15, 3 times 10, 5 times 6. It's going to have to be the 5 and the 6 pair because we need it to make this 1 right here. And the 6 is going to have to be negative. Numbers that multiply to 60. Again, several options there. The only one that's going to give you 17 is 12 times 5. That's a little bit of a trickier pair, 12 times 5. Both positives. All right. And then we can start canceling. Leaving us x plus 3 over x plus 12. All right, now onto our new material for today. We're going to be simplifying monomials. Monomials means it's just one term, which can be several variables, but there's no plus or minus signs separating these like we had up here. So example number 1, we're going to take the numbers, the 10 and the 15, and we're going to see what we can reduce by. If I think about 10 and 15, I know both of those can be divided by 5. So I'm going to reduce each of those by dividing by 5. 10 divided by 5, 2. 15 divided by 5, 3. And then for your x's, you're going to ask yourself, where are there more x's, in the numerator or denominator? Well, I have x to the 5th at the top and x squared at the bottom. So I know I have more at the top. And then I'm going to subtract them. 5 minus 2 is 3. So that means I'm going to write x to the 3rd in the numerator. What's really happening is x to the 5th is 5 x's. And x to the 2nd is 2 x's. And so that one cancels, and it leaves you x to the 3rd at the top. It's just a lot of work to write out all those x's every time. So we just ask ourselves, where are there more? And then write your answer there after you subtract. All right, let's look at the y's. Y to the 8th compared to y to the 3rd. There are more y's in the denominator. How many more? 8 minus 3 is 5. Z's, z to the 10th compared to z to the 9th. More z's at the top. How many more? 1. You could put a 1 right here, or you could leave it off 1 exponents are not needed. And there's our simplified answer. Example number 2. Let's see what we can reduce these by. 24 and 6, we want the largest number. The largest number we can reduce by is 6. Yes, 2 goes into both, and yes, 3 goes into both. But always try to do the largest number to get you the answer faster. So that would give us a 4 and a 1. A's, where are there more A's? There are more A's at the bottom. 8 compared to 2. How many more? 6 more. 8 minus 2 is 6. And then the B's. I have exactly the same amount. B at the top, B at the bottom. Those can cancel out. Also, you could get rid of that 1 in front and just write your answer something like that. 4 over a to the 6th. Or if you'd rather have the 1, you could leave it as well. All right. Then we go into multiplying. For multiplying, you're going to want to gather all of your like terms together in the numerator, and same for the denominator. So we're going to go all the way across the top and figure out what we have. Let's see. I have x to the 7th and another x to the 4th. That would make x to the 11th. So we add the exponents. Then y to the 3rd. There's no other y's, so bring that over. And then you do the same thing for the denominator. Here I don't have any like terms, so I just write them all. And I always like to write them in the alphabetical order. So that way it's the same in the numerator and denominator. Always x's, then y's, and z's. After you've brought everything together, you have the same type of problem we did for examples 1 and 2. I don't have any numbers here, so I don't have to reduce it. I just go straight into asking the question, where are there more x's, numerator or denominator? Numerator, how many more? 11 minus 5, 6. Where are there more y's? Denominator, how many more? 2. 5 minus 3 is 2. Z's, I only have z's in the denominator, so those will stay in the denominator. Example number 4. Start by going across the numerator. Because I have two numbers, 3 and 2, I actually want to multiply those two numbers. So to get 6, and then a to the 1st, add the b's together, b to the 7th, c to the 4th, and then bring down the 8. I always put the numbers first. Then the a, then the b, and no c in the denominator. We've got numbers again, so we want to reduce by dividing by. What's the biggest thing 6 and 8 can be divided by? So I always look at the smaller number, the 6, and see what numbers can go into there. I know 3 can go into there, but unfortunately 8 divided by 3 would get me a decimal. I also know 2 goes into 6. And 8 divided by 2 is 4, so I'm going to reduce by 2. 6 divided by 2. 8 divided by 2. Where are there more a's? Denominator. Where are there more b's? Numerator. And c to the 4th. Nothing to compare it to, so that stays where it was. All right, example 5. Across the top. I went ahead and put a 1 on that end for the missing exponent. Bring the number to the front. And then again, always in the same order in the numerator and denominator. So if you have the m first, put the m first. All right, we need to reduce by dividing by. What number goes into 21 and 7? Again, there's not very many numbers that go into 7, just 7 and 1, so we're going to divide by 7. 21 divided by 7. 7 divided by 7 is 1. More m's in the numerator by 2. More n's in the denominator by 1. And one thing I do want to point out, if you have an extra number in front like this 1 down here, you could get rid of that as well as rid of that 1 right there. So you don't have to, but know that you'll most likely see it written like that. For the back side, we have divide. Important thing to do at the beginning when we are going to divide, take the second fraction and flip it. So I'm just going to rewrite everything in the first equation, in the first fraction. I'm going to put some 1s there. And then I'm going to flip it. So the y to the third goes at the top, and 3x squared y to the 8 goes in the denominator. So just flip that second fraction. After that, we're going to do the same thing we did when we were multiplying. We're just going to gather all the terms across the top, combine them together. Add the y's together. Bring over the z. I've got a number in the denominator, 3. I'm going to put that first, and then line up the x's, add the x's, add the y's, and I do not have any z's. All right. We are not able to reduce because we don't have 2 regular numbers, so I'm just going to leave that 3 down there. Then there are more x's in the numerator by 4, 7 minus 3. More y's in the denominator by 1. I'm just going to leave that 1 off the exponent. And more z's at the top. There are not even any z's in the denominator. There we go. Example 7. Start by flipping this. So I'm just going to do a rewrite of it. Change to multiply. And flip this. Gather across the top. Gather together, comes across the bottom. Put your number first, 30. M to the 9th, add the p's, p to the 6th. Put the number first. I don't have any m's, so maybe you want to put your n's next. Add the n's, add the p's. Reduce by dividing by. Again, largest number, that 15 and 30 can be divided by. Oftentimes, the largest number will be the 15, will be that smaller number. 30 divided by 15 is 2. 15 divided by 15 is 1. Now, be careful not to accidentally add the m and the n. Don't try to combine those. So m stays at the top, n stays at the bottom. Those are different letters. And then more p's in the denominator. 13 minus 6 is 7. All right, our last problem. Flip this last one. First fraction always stays the same. Second fraction, when you're dividing, flips. Notice I added the 1s on the A and the C. Just helps me remember that those are letters that I need to add into the mix. All right, let's bring the numerator together. 12 times 2, 24. Add the exponents of the A's. Don't have any B's. C to the first. Multiply 6 times 3 in the denominator. No A's. Add the B's exponents. Add the exponents of the C's. $18 and 24. And start thinking of numbers that you can divide by both of those. So numbers that can go into 18. First of all, let's try 18. 24 divided by 18. Nope, that's not going to work. That gets us a decimal. Maybe 9. 24 divided by 9. Nope. Maybe 6. Yes, 6 looks like it works. So divide 24 by 6 to get 4. 18 by 6 to get 3. A to the 4th has to stay where it is. There's no other A's. Same with B to the 10th. And C to the 11th ends up in the denominator. More C's at the bottom. 12 minus 1 to get 11.